Some of our unit rates, especially in 7th grade, are going to end up having complex fractions in them. And this is a good example here. So I know that I have two pools that are leaking. After 15 minutes, pool A has leaked 2/3 of a gallon. After 20 minutes, pool B has leaked 3/4 of a gallon. Which pool is leaking faster? So first I need to figure out what is my unit rate going to look like. And I'm going to be comparing how many gallons are leaking and how much time they're leaking. So I'm going to do gallons per hour. And the first thing that I have to deal with here, if I read back through my problem, the information was given to me in terms of minutes. I was told 15 minutes here, and I was told 20 minutes over here. So I have to think to myself, if there's 60 minutes in an hour, and I have a pool that's leaking for 15 of those 60 minutes, that would be 15 out of 60. Well, I could simplify that fraction and figure out that 15 out of 60 is equal to 1/4. So 15 minutes is 1/4 of an hour. I'm going to write myself a little note up here. So this is equal to 1/4 of an hour. And I can do a similar thing with 20 minutes. So 20 minutes out of an hour, and an hour again is 60 minutes. So 20 minutes out of 60. And I can also reduce that fraction. I could divide both the top and the bottom by 20. And I find that that is equivalent to 1/3. So 20 minutes is equal to 1/3 of an hour. So I'm going to make myself a little note here. So now that I have my time in the correct unit in hours, I could start plugging in for my unit rate, gallons per hour. So if we start with pool A, I know that pool A leaked 2/3 of a gallon in 1/4 of an hour. So 2/3 of a gallon would be my numerator, and that takes place over 15 minutes, or 1/4 of an hour. And we learned earlier that a complex fraction is really just a fancy looking division problem. So this is really asking me, what is 2/3 divided by 1/4? So let's write that out so it looks more typical. 2/3 divided by 1/4. And we also learned earlier that whenever we're dividing fractions, we use our keep, switch, flip method to change it into a multiplication problem. So I'm going to keep, switch, flip 2/3. We switch this to a multiplication, and we flip, or we find the reciprocal of the second fraction. So this becomes a 4/1. And if I look at my problem, I know that I can't cross cancel anything. So I'm going to multiply my numerator, 8, multiplied by denominator, and get 3. 8/3, well, I know 3 can go into 8 2 times. So that becomes my whole number. And I have 2 left over, keeping that denominator. So pool A is leaking at 2 2/3 gallons per hour. We have to see now if pool B is leaking at a faster rate or a slower rate. So very quickly, I'm just going to get rid of this so I have some more space. And we're going to set up another unit rate, this time for pool B. Oopsies. There we go. So I'm going to follow that same setup, gallons over hour. And pool B leaks for 1/3 of an hour. It leaks 3/4 of a gallon of water. So 3/4 goes with gallons, so that will be my numerator of my complex fraction. and 1/3 is my time, or my hours, so that's going to be the denominator of my fraction. And again, a complex fraction is just a fancy division problem, so this is really asking me, what's 3/4 divided by 1/3? So I'm going to write it down, 3/4 divided by 1/3. And just like before, in order to solve a division problem with fractions, we change it to a multiplication problem using keep, switch, flip. So I keep the 3/4, I switch the division to a multiplication, and I flip or find the reciprocal of the second fraction, so this becomes 3/1. I can multiply my numerators. 3 times 3 is 9. Multiply by denominators. 4 times 1 is 4. And I simplify. So 4 can go into 9 2 times with 1 left over. And we keep the 4. So pool B is leaking 2 1/4 gallons per hour. So now we have to look back and say, well, what did the question actually want to know? And they asked in the question, which pool is leaking faster? So which pool is losing more water per hour? So if I look back at my answers, I need to compare the 2 2/3 and the 2 1/4. And if you're not really sure which of those is bigger, we know that to compare fractions, we should really have a common denominator. So let me get my pen back here. If I look at my denominators, I have 3 and 4. 12 would be a really nice denominator to use. So I'm going to make 2 2/3 into 12ths by multiplying that fraction by 4. So this becomes 2 8/12. And if I look at my second fraction, in order to make this 4 into a 12, I need to multiply the fraction by 3. Keep in mind, whatever you do to the bottom, you do to the top. So this becomes 2 3/12. And now I can more easily compare my fractions, 2 8/12 versus 2 3/12. Obviously, 2 8/12 is the larger number, so that tells me that pool A is leaking at a faster rate.